Hey guys, in this video the brilliant Mr. B is going to be taking you through working with angles for further maths. So some advanced examples here. Now you could use this for your further maths, GCSE, level 2 or level 3, or you can use this video as an introduction if you want to get a head start on what you're going to be covering at A-level maths. Now there are loads more examples of this just waiting for you over on my website.
We are going to revise angle facts. I'm going to start off with the easiest ones and then work all the way up to the hardest ones, like circle theorems. Now, this all comes down to how many degrees are in a circle. And circles have a total of 360 degrees. Now, why is that number? There's no particular mathematical reason why it's that number. It's been chosen. The reason why that number's been chosen is it has lots of factors. So you can divide it by 2, 3, 4, 5, 6. You can divide it by 8 and 9 and 10 and 12. So it can be divided a lot of different ways. So just a nice number that's been chosen. So when you have angles around a point, so let's just draw this on the circle. So we have a point in the center of the circle. It must be the center of the circle. It can't be just any old random point. And you have angles being made from the center like this. So here we have 3 angles around a central point. All 3 of those have to add up to 360 degrees. Now we can derive other facts from this. So for example, if you have a straight line and the straight line has an angle on it like this, that is going to have a total of 180 degrees. The reason for that is that on a straight line, you can see I've tried to draw a semicircle there, and a semicircle is half of a circle. So half of 360 is 180. We get something called a right angle, where the total is 90 degrees. And we normally signify that just with this little box symbol. That tells you we have a 90-degree angle. Why is it 90 degrees? Because that's half of a semicircle. So we're just halving each time to derive different facts. So how do we use them? Well, in our question, we have to identify what we have. Do we have angles around a point, which would be 360? Do we have angles on a straight line, which would be 180? Or do we have angles in a right angle, which would be 90 degrees? And I can identify on here that we do actually have a straight line, and all the angles are coming out of that straight line. So this is going to have a total of 180 degrees. So how do we work it out? It's the same for most of these questions. Add up the angles you've been given as clues. So we've been given 57 as a clue for the first angle. Let's tick it off. And the second angle is also 57 degrees. So let's tick that off. So let's add them together. That is going to give us 114 degrees. So now we know what part of the semicircle adds up to. The part I'm highlighting in blue adds up to 114 degrees. That must mean that the remaining section, which is labelled X, must be another number that will make it all add up to 180. So the method here is we take the 180 degrees that the entire thing adds up to, and we take away the 114 we've been given as a clue, and whatever is left over is the angle X. Now, usually there's a 0 at the end of 118, 360, and 90, so you're going to have to borrow one. You do 10, take away 4, 7, take away 1, and 1, take away 1, which is 0. So our answer is 66. So now I'm going to write a final answer. X is equal to 66 degrees. And if you want to check your answer, try adding together the 57, the second 57, and the 66. They should all add up to 180 degrees. One final detail here is that the two 57s may not be labelled because they're both the same. And when you have angles at the same size, you might see something like you might see a little dash on it. Or alternatively, it might be that the arc has 2 arcs. And what this means is the angles are the same size. So it might be that one of them's labelled and then they're both labelled with a dash to let you know that they're both the same size. Moving on to the next question, we have another set of angles, and the first job is to recognise, is it a circle, is it a semicircle, is it going to be a quarter circle or right angle? So just tracing around the angles here, we can see that we have a full circle. That means that it's going to add up to 360 degrees. So we follow the steps we did before, add up all of the clues you've been given. So we've been given 73 degrees, 37 degrees, and 174 degrees. So let's add all of these together. So add up the units, which should give us 14. Add up the tens, which should give us 18. and then add up the hundreds, which will give us 200. So altogether, we have 284 degrees. So just shading what we found the part of the circle that I'm colouring in blue. We now know the size of all of this altogether. What we don't know is the one section that's left over that's labelled X. Now we know that all of it is going to add up to 360 degrees. So we take away the clues we've been given, whatever is left over is going to give us the angle X. So again, we're going to start off by borrowing one, and we can do 10 take away 4, 5 take away 8, so we're going to borrow one again for that. 15 take away 8, and then 2 take away 2, which is 0. So angle X, write down your final answer, is going to be 76 degrees. And you can check your answer by adding together all 4 angles, the 3 we're given at the start and the 76, and they should all add up to 360 degrees. So now we're going to have a look at different kind of polygons. We're going to look at triangles first. Now, with the triangle, it's not really clear, well, what is this going to add up to? I would just highlight the angles here. Again, it's not very clear what they're going to be. Now, what you will find is if you cut off the corners of all 3 of those and you line them up, you can actually make a semicircle out of the 3 angles in a triangle. That means that triangles add up to 180 degrees, and that's derived from a circle being 360, because those 3 angles will make a semicircle, so the half of that. So to solve the triangle question, it's again exactly the same method. Add up your clues. We have 33 and 54. That's going to give us 87. And we know it's going to add up to 180 degrees. So we take 180 degrees, we take away the 87, and whatever's left over will be the size of that 3rd angle. So again, we'll have to borrow one. 10 take away 7, 7 take away 8, so we'll borrow one from there. So it's 17 take away 8. So that gives us 93. So we say that the angle labelled C is 93 degrees. So just make sure you write out a final answer so it's nice and clear what you're saying, so your teacher or your examiner doesn't have to hunt around for your answer in your work, Now, from a triangle being 180 degrees, you can work out any other polygon, and you do them by cutting them up into triangles. So for example, let's have a look at a square. How many degrees is a square going to add up to? Well, all you need to do is take a corner, cut it in half, and you have 2 triangles. Both of them will be 180 degrees, so a square will add up to 360 degrees. Let's say we had a pentagon, which I'm going to try and sketch here. What does a pentagon add up to? Well, again, take a corner, doesn't matter which, but from that corner, draw a line to every other corner, and you'll get this. So we've got a 180-degree triangle, and a second 180-degree triangle, and a third 180-degree triangle. So you add all of those up, and you have 540 degrees. So using that method, you can calculate all the angles in any sort of regular polygon is going to add up to. And actually, this will work for irregular polygons as well. The last thing I'm going to show you is something called interior and exterior angles. So just zoom in on one corner of the pentagon. So I'm just going to colour in which corner it is. So it's this one here. If this is a regular pentagon, and that means that all the sides are the same length, we can actually calculate the size of one angle. And the way you do it is you say, well, okay, it all adds up to 540 degrees. It's got 5 sides, so I'm going to divide by 5, and that gives you 108. So, in a regular pentagon, that will be 108 degrees. Now, if it's an irregular pentagon, it could be anything. If it's an irregular pentagon, all the sides are different lengths. They would all add up to 540, but each one wouldn't be 108. The last thing we can talk about here is this is called an interior angle, and you might be asked for the exterior angle. Now, the exterior angle is when you extend the side, so we'll just take the side, and we keep going. And so the exterior angle is the angle I'm labelling now. And you can see both of those add up to 180 degrees because it is a semicircle. So to find that, you just take 180, you take away the 108, and that gives you 72 degrees. So the exterior angle is 72 degrees. And sometimes what might happen is they'll give you the exterior angle and they'll say, what's the interior angle, and therefore which shape is it? So if you give them 72, you can work out the interior is 108, and so you know it's a pentagon. The next thing we'll look at angles in parallel lines. So set some parallel lines up to show you what I mean. And for each one, if they are parallel lines, they're going to have a little arrow like this, just to show that both of those lines are completely parallel. It doesn't mean the same length or anything like that. It just means that they are going in the same direction. And if you extended those lines, they would never, ever meet. So you can think about things like train tracks as an example. Now, we know things about angles in parallel lines. So for the first one, I'm just going to draw on two angles. And there's something to say about those two angles I'm going to highlight. And that is that these two angles are equal. And we have a name for this, and we call it alternate angles. So the alternate angles. Now, to help me remember this, there is a little tip for you. What you can do is you can highlight the angle. And what I mean by that is the two lines that make up the angle. So I've highlighted the first angle and now I've highlighted the second angle. And they join up. And what you can see is that you've made a Z shape. So if you see a Z shape in parallel lines, you know that they are alternate angles and they are equal. However, there's a really important thing here, and that is that very often exam paper will ask you to explain why the angles are the same. And if you say, oh, they're the same because of Z angles, you will lose a mark. You must use the correct terminology, and that is alternate angles. So let's look at the next one. So again, I'm going to just highlight two angles here. And there's something that we know about these angles. And what it is, these ones aren't equal. These ones add to 180 degrees. And there's a name for these as well. And it's co-interior angles. And again, there's a little clue for these. You just highlight the two angles. So again, the two lines that make up the angle. And do it for both. There's a little gap, just extend it to the joint up. You can see that it makes a C shape. So again, if you see a C shape in parallel lines, you know that they add to 180, but you will lose a mark if you don't use the correct terminology. You'll have to say these add up to 180 because they are co-interior angles. You can't say it's a C angle. So in the same way, let's have a look at the next set of parallel lines. I'm going to highlight two angles here as well. And there's something we can say about these angles. And for these ones are also equal. And there's a word for this, and we call these corresponding angles. Corresponding angles are equal if you're using a sentence. And again, as a clue, what you can do is again highlight the two lines that make up both angles. And if you give an angle as a clue and an angle to look for, you can highlight them, and whatever letter they make is your clue. Now, there's a gap here, so I'll join them up, and we can see that this is making an F shape. But again, when asked to explain yourself, don't say they're an F shape, so they're equal, or they're F angles. You must use the correct terminology, and that is that these are corresponding angles. And looking at the last one, I'm just going to highlight two angles here. Now, I could highlight the left and right and have the same thing, but I'm going to highlight the top and bottom here. There's something we can say about these angles. And these angles, these are also equal. Three of these facts give you equal sizes, but one of them they add up to 180. So don't always think it's going to be the same number again. With one of them, you're going to take away from 180. These ones are called opposite angles. And opposite angles are equal. Now, these ones aren't parallel. These lines cross over each other. They intersect. So they're not parallel. But again, if you just highlight the two lines that make up each angle, so the top one and the bottom one, again, you can see a letter as a clue. And this is an X. But again, really, really careful here. Do not say X angles. You must say opposite angles are equal. There's one more thing to cover here. Now, we've gone through it already. But let's look at these two angles. Think about what would you think would happen with these two, and hopefully you can see that these two angles, they are on a straight line. They're going to add up to 180. Now, you could call these adjacent angles. They are next to each other. But when you're proving this, you'll just say that angles on a straight line add up to 180. So there's no new terminology for that one. So looking at our question, we have two sets of parallel lines. Now let's get the arrows on here. These are parallel. We have an angle as a clue, 100 degrees, and an angle we're looking for, the X. So the method here is you highlight the two lines that make up each angle. There's the first one, there's the second one, next to the join up, and just observe what letter you have there. Well, we have it's a backwards Z, but that still counts. These are allowed to be rotated. So we have a Z shape. So what do we do? So we need to do two things. Firstly, we recognize that these are alternate angles. So we're going to write that X is equal to 100 degrees for one mark. And then most of the time, you have to explain yourself. Why is X 100 degrees? And we have to say, because alternate angles are equal. And then that should be the full 2 marks. And again, I can't stress this enough. If you write down X angles are equal, you are losing 1 mark. You'll get 1 for the 100 degrees. If you're very unlucky, it might be a 2-part question. It might be 1 mark for both things together. So you might lose all the marks. You're really unlucky. So pay really careful attention to the correct terminology. They are alternate angles. Moving on to the next question. Again, we have 2 parallel lines. We have an angle as a clue and an angle that we are looking for. So I'm just going to highlight the angle X, the 2 lines that make it. I'm going to highlight the angle 136, the 2 lines that make it, and observe which letter I have. And it's a C shape, which is going to be co-interior angles, which add up to 180 degrees. So let's take 180, take away the clue we've got. So much like when you had angles on a line or at a point, to borrow 1 step, 10 take away 6, 7 take away 3, and 1 take away 1. That gives us 44. So now for our final answer, we're going to write down that X is equal to 44 degrees, and we need to write a reason, because co-interior angles add to 180 degrees. So we have our answer, and we have our reason, and we should be getting full marks. And before we move on, just think about how quick that question was. That was done in under a minute. So actually the maths here is really easy. It's just remembering all of the correct terminology and all of the correct angle facts in parallel lines. Moving on to the next question. Now it's a little bit more complicated. Now we still have a set of parallel lines, but let's just use our method and see what happens. So I'm going to highlight 97 and I'm going to highlight the X. And what you'll see is that even though I extend, these are not going to be touching each other and forming a letter. So what do we do? Well, we're going to have to basically start finding other angles because it's going to be more than one fact to connect these two together. Now, the easiest is usually the X shape. It looks like one across here, but again, you can rotate these. So that means that the opposite angle here, this is also 97 degrees. And then can we now connect these up and make a letter? Well, I mean, another thing we could do is we could do the same thing with the X. And what you'll find here is, I could actually solve this in one fact straight away now, but you might just want to build up multiple angle facts. And some of them you won't need to get the final answer, but it's not going to make a difference. It's just being very thorough and making sure that you don't make any mistakes. So with the X, the opposite angle to that is also going to be X. And now these are a little bit close together. You might be able to see that we can connect these up now. And we can connect that up by highlighting the X, the second one that we drew, highlighting the 97, again the second one, and now this is making a Z shape. So this is alternate angles. This is telling me that X is going to be 97 degrees. Now, what are the reasons? Well, there were 2 different reasons. The first one was that opposite angles are equal, and that was used to find the X and the second 97. And we also use the alternate angles are equal. Now, before I move on, you might want to do other things here. So we've got the answer now. There are other things you could have done here. So, for example, the second 97 and the original X, they are in an F angle together. They are corresponding angles. And also the original 97 and the second X, they are also corresponding angles. So you could have said opposite angles are equal and corresponding angles are equal if the working out on the diagram was different and represented that. Other things you can do is that you can work out extra angles. For example, we know that the angle I'm highlighting here, this one, is going to be 83 degrees because it's on a straight line with 97. Let's just highlight that. So a straight line with a 97 degrees. And that means that we know that the opposite to that is 83, and it's going to be the same at the top as well. So if you get a bit lost with diagrams like this, just keep finding as many angles as you can. Keep finding more and more angles, and eventually you're going to get the angle that you need to get that's the actual clue you need for the final answer. But don't be worried having lots of extra angles on them, as long as your final answer is correct and your reasoning is correct. The next thing we'll look at are circle theorems. Now, for the first circle theorem we're going to have a look at, I've drawn a circle, and what we have in the circle is a chord. Now, a chord is a line that goes from a point on one edge to the point on another edge. So we call that a chord. Now, the first fact is that if we draw a triangle from this chord, so for example, what if we draw, I'm just going to sketch this like this. We've drawn a triangle, and that triangle has an angle at the end, which we'll call X. Now, we can draw lots of different triangles from this chord. We could draw a triangle over here. Now, this chord, the angle is also X. It's the same size. I could even draw another one. and that angle is also x. So for our first fact, we can say that angles drawn from a card are equal. Let's write that down. So we'll look at our first question. It's not really clear what this is. It's because the card hasn't been drawn on the diagram, and we're going to have to do that. And the card is here. So what you're trying to do is, the two angles you've been given, if they don't make a triangle, then you're going to have to make them create a triangle. And by triangle, I'm not talking about, I'm just going to highlight it quickly. I'm not talking about this. When I'm saying that these have to make a triangle, both points of the triangle, in fact, all three, have to touch the edge of the circle. So that one's not good enough. It has to touch the edge of the circle. All three corners touch the edge of the circle. Let's just highlight that. Let's got 1, 2, 3 corners touching the edge of the circle. And then we'll draw the second triangle. And notice they're going to overlap here because they both use the same card. And again, all three edges, or we could say vertices for the corners actually, they're all on the edges of the circle. That means that we can say that x is equal to 34 degrees. Both angles are the same size. Why they're the same size? You'd write down angles from a card to the edge are equal. And just like the parallel line questions, you may be asked to write an explanation. And that's the explanation you can use. Before we move on, there's one extra little detail to this, and that is that what if the card goes through the centre of the circle? So again, the card goes from one edge of the circle to another edge of the circle, but this time it's going through the centre. So two things would happen here. Firstly, the card would be the diameter, because diameter also goes from one edge of the circle to the other, but through the centre. The other is, when you draw the triangle shape, what would happen is the angle would be 90 degrees. So if the diameter is equal to the card, then the angle you produce would be 90 degrees. Now, the next fact we're going to look at also is about a card, again, going from one edge of the circle to another. And like we just saw, you can draw a triangle from that, which gives you an angle. I'll call that x. Now, for this one, this is all about what happens if, instead of drawing a second triangle all the way to the edge and it'll be equal, what happens if we draw it to the centre of the circle? And what would happen is we can see the angle is larger, and it will just mean that the angle is actually exactly twice as big. So we'd call it 2x. So how can we describe this? Well, we can say that So again, when we have a look at our question, as usual, the card has not been drawn on, which makes it a little bit more complicated, and you have to spot where the card is. So the card is going to be here. The way to find it is to look at your angle and think, does this make a triangle? And if you look at the 52, we can draw a line down one side, we can draw a line down the other side, and so the card must be the thing that completes the triangle. And again, all three vertices of that triangle are on the edge of the circle. And looking at angle x, again, we can draw the two lines that make it up, and we can think, well, how would we make this be a triangle? We'd have to join up the two lines. And this time, two of the vertices are on the edge of the circle, but the third one is in the center. So what this means is that x is twice as big as 52. So what would we do? Well, we can write x is equal to 52 times 2, which is 104 degrees. And again, for an extra mark, you'd be asked, well, why is this the case? I would say because the angle from a card to the center is double that angle to the edge of the circle. Now, as a related circle theorem here, what would happen if instead of going to the center, we went to the opposite edge? I'm just going to sketch on what I mean. So in blue, we'll do a dotted line because it's not part of the question. What would happen if the kind of pink triangle was pointing the opposite direction? Well, I'll just do a little sketch of that. You think about what kind of shape this is made. This is made a four-sided shape. It's a quadrilateral. It's got four angles. Now, this is called a cyclic quadrilateral. It's called a cyclic quadrilateral because it's a quadrilateral and it's inside a circle. All four vertices of the quadrilateral touch the edges of the circle. Now, the cyclic quadrilateral, obviously all the sides add up to 360 degrees, but we've just labelled the different angles. Let's call them A, B, C, and D. What you'll find in a cyclic quadrilateral is that A plus C is 180, and you'll find B plus D is 180. So what that means is, in a cyclic quadrilateral, the opposite angles are equal. Now looking at the last question, we have a point on the outside of the circle. And there's a few things we can say about this. So the first thing is, if us highlight two of the lines, and then we're going to look at what's common about these lines. So firstly, both of these lines start at the point, and they both end touching the circle. And we call this a tangent. A tangent is when a line touches a circle and it continues. So if I label that from the point, touching the circle, and then continuing onwards, we would call that a tangent. Now, when the tangent hits the point on the circle, what we can say is that these are equal because they're both doing the same thing. Both of these lines are starting at the point and they are finishing at the tangent. Again, starting at the point on the outside of the circle and finishing where the tangent touches the circle. Both of those are the same size. So we can say lines from, you might want to add a bit more detail to the lines from a point on the outside of the circle to where the tangent touches the circle are equal. The other thing we can say is that on this diagram, we have two radiuses or radii from the center of the circle to the tangent. Now, again, both of these are going to be the same length because they are both radiuses. What we can also say is that the angle between the radius and the tangent is a right angle. So now we've got this circle theorem out of the way, we can have a look at our question. And to start with, it only looked like we had an angle, 70 degrees, on the outside of the clue, and an angle on the inside, and no apparent connection between them other than the tangent. But now we know two extra angles. We know the two 90-degree angles. So now we've got to think, well, what shape is this? It's a kite. We've got a four-sided shape. And I'm just going to highlight it on the inside so you can see it. But as a four-sided shape, this is going to add up to 160 degrees, 360 degrees, sorry. So add up all the clues you have. We have our 70 degrees we started off with. We have the two 90 degrees that we know about because the radius touches the tangent. And we can add up all of our clues. And so that is going to add up to 250 degrees. We know that a kite is a quadrilateral. It's going to add up to 360 degrees. So we can take away the 250 degrees, 0 take away 0, 6 take away 5, 3 take away 2, and that gives us 110 degrees. So we can say that x is equal to 110 degrees. Why? Again, talk about the tangents and talk about how the angle between the radius and the tangent is 90 degrees, which gives us the two extra clues. Before we finish, there's one circle theorem we haven't mentioned, and that's the alternate segment theorem. Now, with the alternate segment theorem, it is also talk about a tangent, and we can see we've got a tangent here to a circle, and you have an angle that's between the tangent and this triangle that I've drawn on the inside of the circle. Now, this angle is equal to the opposite angle inside the triangle. These are both the same size. It's not the same size as the angle that's adjacent to it, and it's not the same size as the angle that's on the same line up here. You see that this line, both angles touch it, and this angle is right next to the line, the tangent and the angle. So it's the angle that's completely unconnected to the green angle on the tangent that is the same size. And that's a bit of a mouthful to explain. So when you ask, well, why are those two angles the same size? You just say it's the alternate segment theorem, or you can just write AST.
Ouch! This is why in some videos I have explained scratches.